For dilution, I use the formula C1V1 equals C2V2. For the first question, to 35.0 milliliters of sodium nitrate is added 45.0 milliliters of 0.200 molarity barium chloride. The concentration of nitrate is 0.335 molarity in the final solution. Calculate the initial concentration of the sodium nitrate solution. So we are given the initial concentration of nitrate and sodium nitrate, which is 0.335 molarity, because it is a 1-to-1 dissociation equation. Now using the M1V1 equals M2V2 formula, plug in the concentrations and volumes of the liquid. Now multiply the 0.200 molarity and 0.080 liter and divide it by 0.035 liter. The answer should come out to 0.457 molarity, which is the sodium nitrate's initial concentration. Moving on to concentration of ions, what is the concentration of each type of ion in a solution made by mixing 150.0 milliliters of 0.450 molarity sodium chloride and 380.0 milliliter of 0.375 molarity calcium chloride? To solve this question more easily, we can assume that no reaction occurs. It is simpler to deal with them separately using the C1V1 equals C2V2 formula. So first, calculate the concentration of ions as a result of the dilution of the sodium chloride solution. Now calculate the concentration of ions as a result of the dilution of the calcium chloride solution. Now finally, just calculate the concentration of the chlorine ions in the final solution. The concentrations in the final solutions are as follows. So in organic chemistry, organic compounds contain carbon atoms and are bonded to other carbon and hydrogen atoms. They may also contain other elements like halogens, nitrogen, oxygens, etc. However, compounds like carbonates, carbies, and other oxides of carbon are not organic compounds. Here are the general rules for bonds according to each element. So hydrocarbons are compounds containing only hydrogen and carbon. Here are three main types of hydrocarbons. The first one being alkanes. Alkanes only contain single bonds, and the general formula is CnH2n plus 2, where n equals 1, 2, 3, and so on. They end in ane, and it is a saturated hydrocarbon. Side chains called alkyl groups can be added to the main alkane chain. Alkanes with subchains is called a substituted hydrocarbon or a branched hydrocarbon. They can also include halogens. Structural isomers are a form of some molecular formulas that have more than one structural formula and have different chemical properties.